In this lecture, I would like to evaluate some more problems on beta gamma functions by using another theorem called a theorem connecting beta of m1 by 2 is equal to 2 power 2m minus 1 beta of m. And from this we can deduce the formula and deduce the duplication theorem or duplication identity, duplication formula. The formula is as follows: gamma of 2m is equal to, observe one thing carefully, I am writing duplication formula. The duplication formula is, I want to say about this duplication formula in terms of gamma. So this is 2 power 2m minus 1 by root pi, and this is gamma m into gamma of m plus 1 by 2. Observe the theorem and the deduction from the theorem, which is called the duplication formula. Beta m1 by 2 is m comma 1 by 2 is 2 power 2m minus 1 beta mm. From this, I want to get all gamma. Gamma of 2m is 2 power 2m minus 1 by root pi into gamma m plus half. Now, let us see the proof of this. So, now, beta of m comma 1 by 2 is equal to, I want to use the formula for beta, twice 0 to pi by 2 sine power 2m minus 1 theta cos power 1 by 2 is there, so 2 into 1 by 2 minus 1 theta d theta is equal to twice 0 to pi by 2 sine power 2m minus 1 theta. This is 2 by 2 1, 1 minus 1 0, cos power 0 1, so this is simply d theta. Call this as 1. Let us consider 2 power 2m minus 1 beta m comma m, which is equal to, I am writing 2 power 2m minus 1 beta mm, the same formula 2 power 2m minus 1 into twice 0 to pi by 2 sine power 2m minus 1 theta cos power 2m minus 1 theta d theta. This is equal to 2 power 2m minus 1 into 2. I am not going to simplify this because 2 power 2m minus 1 into 2. Simply I want to leave like that. 0 to pi by 2. Look at this. This is sine theta cos theta power 2m minus 1. So I want to supply 2 here. 2 sine theta cos theta power 2m minus 1. I have to divide by 2 inside of the bracket d theta. So this is equal to 2 power 2m minus 1 into 2, 0 to pi by 2, 2 sine theta cos theta is sine 2 theta. So sine 2 theta whole power 2m minus 1. Look at this. There is 2 inside in the denominator. So that will be 2 power 2m minus 1 d theta. This 2 power 2m minus 1 comes out. So this will be 2 power 2m minus 1 into 2 by 2 in 2m minus 1 integral 0 to pi by 2 sine 2 theta whole power 2m minus 1 d theta. I can cancel these two, so I'll get twice integral. Now I want to simplify this, so let 2 theta is equal to alpha. This implies 2 d theta is d alpha. So sine alpha power 2m minus 1. What about sine alpha power 2m minus 1? What is d theta? D theta is d alpha by 2. Fine. Now what are the limits? The limits of theta are 0 to pi by 2. So limits of theta are 0 to pi by 2. Now let us evaluate the limits of alpha. If theta is 0, alpha is 0. If theta is pi by 2, alpha is pi. So I can cancel these two and these two. So this is 0 to pi sine alpha power 2m minus 1 d alpha. This I can write as twice 0 to pi by 2 sine power alpha power 2m minus 1 d alpha. How this is valid? In what way I can write down this? This is a simple way is 0 to a sine can be written as, if sine of pi minus alpha is sine alpha, so 0 to 2a will be twice 0 to a. So twice 0 to a by 2, so it's pi by 2. Now look at this, call this as 2. Look at 1 and look at 2. RHS of 1 and RHS 2 are same. Hence, beta of m1 by 2 is equal to 2 power 2m minus 1 beta m n. That is the main theorem. I mean, now we can evaluate gamma 2m as this. We have to use beta. So let us use that one. So this simplifies. Now, what is beta m1 by 2 in terms of gamma? It is gamma m into gamma 1 over 2 by gamma of m plus 1 by 2, which is equal to 2 power 2m minus 1. What is beta mm? Gamma m into gamma m by gamma of m plus m, which is 2m. Now I have, you can see, you can compare these two, gamma m into gamma f. So I can cancel this gamma m because gamma m is non-zero. So this implies I'll bring this gamma 2m into the numerator. So I'll get gamma of 2m, which is equal to 2 power 2m minus 1 gamma m. I'll bring this gamma m plus half to this side. So this will be gamma m plus 1 over m plus 1 by 2 by gamma half. Gamma 2m is equal to 2 power 2m minus 1 gamma m plus 1. But what is gamma half? It is root pi. So this is equal to 2 gamma m plus 1 by 2 by root pi, which is this formula. Simply it's gamma half is root pi. So I could get this deducing from this. If I put m equal to m, so beta mm I'll get. a very useful one. Now I will evaluate using this, I will evaluate a small problem from this. Let us see a, what is the case when m equal to 1 by 4. How do we guess, or what is why we should assume m equal to 1 by 4? Let us see. If m equal to 1 by 4, this is gamma into 2 1 by 4 is gamma 1 by 2 is equal to 2 power 2 into m is 1 by 4 minus 1 by root pi into gamma of m is 1/4 into gamma of m is 1/4 plus half. This implies gamma half is root pi is equal to, this is 1 over 2, so 2 power 1 by 2 minus 1 by root pi into gamma in 1 by 4 gamma 3 by 4. So this implies I need to write gamma 1 by 4 gamma 3 by 4 is equal to, I want to multiply by root pi, so root pi into root pi is pi by, this is 2 power minus half, so this is pi by, this is root half, so pi into root 2. So this is m 3 by 4 gamma 3 by 4 gamma 1 by 4 is root 2 pi. Thus gamma 3 by 4 into gamma 1 by 4 is root 2 pi. We'll use, now I will again recall a problem which I have done already. Integral 0 to pi by 2 root tan theta d theta. I want to, in the beginning, in my previous lecture, I told you that integral root tan theta d theta, I have assumed this. Now I will prove this. Integral root tan theta d theta is 0 to pi by 2 sine root sine theta by root cos theta d theta, which is equal to 0 to pi by 2 sine power half theta cos power minus half theta d theta. Now I want to multiply by 2 and divide by 2. 0 to pi by 2 sine power half theta cos power minus half theta d theta. This is equal to 1 over 2. What is this? This is beta of 1 over 2 plus 1 by 2 comma 1 plus minus half by 2, which is equal to 1 by 2 beta of, this is 2 plus 1 3 by 2 by 2 3 by 4, and this is 1 by 4. When m equal to 1 by 4, what is this? Is 1 by 2 gamma 3 by 4 gamma 1 by 4 by gamma of 3 by 4 plus 1 by 4 is 4 by 4, gamma of 1 is 1. So this is equal to 1 by 2. Now what is this? Gamma 3 by 4 into gamma 1 by 4 is root 2 pi. So if I cancel this, I'll get pi by root 2. So integral 0 to pi by 2 root tan theta d theta is pi by root 2. This is the usual way of doing a problem for this kind of integrals. After doing this, one more result on beta functions is, it's a property you can say, beta of m comma n is equal to beta of m plus 1 comma n plus beta of m comma n plus 1. This is also very useful result to prove many of the integrals, definite integrals in fact. So let us look into the RHS. So consider beta of m plus 1 comma n plus beta of m comma n plus 1 is equal to, this is beta of m plus 1 comma n is integral 0 to 1 x power m plus 1 minus 1 1 minus x power n minus 1 dx plus integral 0 to 1, this is x power m minus 1 1 minus x whole power n plus 1 minus 1 dx. This is the formula that I am using, is equal to 0 to 1. This is x power m. So x power m 1 minus x power n minus 1 dx plus integral 0 to 1 x power m minus 1 1 minus x power n dx. Now, this is the sum of two integrals. The limits are 0 to 1, so I can write down under one roof 0 to 1 x power m 1 minus x power n minus 1 plus x power m minus 1 1 minus x whole power n dx. Let us further simplify this. This is 0 to 1. I can take x power m minus 1 from here. If I take x power m minus 1, I will have x here. And also, I want to take 1 minus x power n minus 1. So what I did was x power m minus 1 and 1 minus x power n minus 1 was taken as a common factor for these two. So I will get x plus, if I take 1 minus x power n minus 1, I will be left over with 1 minus x dx. So this is equal to integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 dx, which is nothing but beta mn. So this is one of the properties. Beta mn is beta m plus 1 comma n plus beta of m comma n plus 1. And there are many other results which gives a lot of information on beta and gamma functions. But at this point of time, I would like to work, or I would like to evaluate a small problem like evaluate 0 to pi by 2 root sine theta d theta into 0 to pi by 2 1 over root sine theta d theta. At this point of time, I have to clarify one thing. Don't get confused by multiplying root sine theta, because the limits are under 0 to pi by 2. If it is plus, you can add under the roof, under the same roof 0 to pi by 2. But at this point, it is not correct. Or even, this is not correct. You have to do it separately. So, I'll call I1. Or simply you can write down like this, 0 to pi by 2. sine power half theta cos power 0 theta d theta. Of course, I have to put a 2 here so that I want to reduce it to the form of beta. Again, I will write down 1 over 2 into 2, 0 to pi by 2. 1 by root sine theta is sine power minus half theta cos power 0 theta d theta. This is equal to 1 over 2. This is beta of half plus 1 by 2 comma 0 plus 1 by 2. Again 1 by 2 into this is beta of minus half plus 1 by 2 minus half plus 1 by 2 0 plus 1 by 2. So this is equal to 1 by 4. This is beta of 2 plus 1, 3 by 2 by 2, 3 by 4, comma 1 by 2 into beta of 1 by 4, comma 1 by 2. Let us convert into gamma. This is 1 by 4. Beta is gamma of 3 by 4, gamma 1 by 2 by gamma of 3 by 4 plus 1 by 2 into gamma of 1 by 4, gamma of 1 by 2 by gamma of 1 by 4 plus 1 by 2. Now, this is a simple way of doing things is this is equal to 1 by 4. Gamma half is root pi. This is root pi. So you'll get pi. Pi into gamma of 3 by 4, gamma of 1 by 4 by gamma of, look at this. This is 5 by 4 into, this is 3 by 4. So what I can do is I can cancel these two. So ultimately I'll get pi by 4 into gamma of 1 by 4 by gamma of 5 by 4. If you want, you can further try for 5 by 4 can be written as 1 plus 1 by 4. So this is pi by 4, gamma of 1 by 4, gamma of 5 by 4 is gamma of 1 plus 1 by 4. So this is, actually I can write down 1 by 4 plus 1, so this is pi by 4, gamma 1 by 4. This is gamma of n plus 1 is 1/4 gamma 1/4. So you can cancel. So this is pi. You can cancel this 4 and 4, so you'll get pi. So integral 0 to pi by 2 root sine theta into root 0, into 0 to pi by 2 1 by root sine theta d theta is pi. Whatever the problem of this kind, you have to do it separately. This is what for beta gamma functions. And most of the problems on this. Now, even though it is not in, I mean, it's not right now connected, but I want to introduce a small integral which we can deal later on. Definition of an error function or probability integral function is denoted by ERFX. error function fx and defined by er fx is equal to integral 0 to x e power minus t square dt 2 by root pi. So error function is, or probability integral function is, er fx is 2 by root pi 0 to x e power minus t square dt. I will define here the complementary of er fx as 1 minus er fx. So complementary function and error function, both are defined. Let us see a small observation, small property on this, a few properties on this. The first property is, what is the error of f minus x? It is here fx with a minus sign. It's very simple. Put x equal to minus x. So 0 to minus x. Change the integral. So you will get 2 by root over pi 0 minus, put a minus x equal to y. So you will get error function. Minus error function is error function. What about error function of 0? Error function of 0 means if you put x equal to 0, so the integral will be 2 by root pi 0 to 0 e power minus t square dt, which is equal to, this is 2 by root pi into 0, because it is between the limits. So error function of 0 is 0. Let us see error function of infinity, because x runs up to infinity. So 2 by root pi 0 to infinity e power minus t square dt. Already I have evaluated this in the earlier class. So 2 by root pi into root pi by 2, so which is 1. So error function of infinity is 1. This is called Gaussian integral. Let us see error complement function plus error complement minus fx. This is 1 minus error fx plus 1 minus error fx, so you will get 2. Simply write down, this is, what is error fx? 1 minus error function plus error 1 function means 1 minus error f of minus x, which is equal to 1 plus 1 is 2 minus error function. This is error minus function. Just now we have seen error minus f minus x is minus error of x. So minus of minus will become plus. So these 2 will go out. So error is 2. Now there are some other important issues on this, but we are not concerned with this. What is the connection between beta gamma? That can be done in the later lectures. I would like to wind up this lecture by looking at some of the problems, throwing as an exercise for you. And I will appreciate if you work on this and then come back with any solution or any doubts. So one is integral 0 to pi by 2 root cot theta d theta. Remember, this is something like root tan theta, 0 to pi by 2 root tan theta. So 1 over root tan theta. And this will be very interesting also. 2. Integral 0 to 1 by root 1 minus x power 4 dx. 3. Integral 0 to 1 x power 5 by root 1 minus x cube dx. For the second problem, try with x square equal to sine theta. And for the third one, put x cube equal to sine square theta. So the hint for this is x square equal to sine theta. For this, x cube equal to sine square theta. Try. Fourth one, x cube log 1 by x whole cube or whole power 4. I'm 0 to 1. 0 to pi by 2, 0 to 1, 0 to 1, 0 to 1. What about this? 0 to 2. I mean, so far you do not have 0 to 2. You have only 0 to 1. E power minus x square by into it is given 0 to 2, neither 0 to 1 nor 0 to infinity. So try. Zero to infinity, x square e power I can write down 0 to infinity x square e power minus x power 4 dx. I mean, I don't want to give a hint for this. Try. Already I have given an exercise, so it's try. This is simple. There is no problem for this. Putting x square equal to t or something, e power minus x square you have to get. So the hint, this easily can be seen. This can be easily seen. Sixth one. See, so far we have seen a different variety of problems on this, but we have not seen something on beta functions. Beta of something like the evaluation of beta. Beta m plus 1 comma m plus n, that can be seen. Beta of m plus 1 comma n by beta of m comma n plus 1 is equal to beta m comma n plus 1 by beta of m comma n plus 1 is beta of mn comma n plus n. A very interesting problem. How do you solve this? See, the aim of this is try to use the methods which we know, like beta m plus 1 comma n, you know the formula. So either you can show that n into beta of m plus n comma n is beta m comma n plus 1 into beta of m comma n plus 1. You try all those methods. So this is an interesting problem. Show that these two are equal. Similarly, these two are equal. Enough. These two will be equal. So this is an interesting idea for this. So I will wind up with this kind of problems, and I hope the problems will be very interesting and will give you a lot of information.